Alright guys, we're going to do another complex number. This time we're going to have some fractions or rational numbers, right? When we see the word rational numbers, right? What we should see is ratio, right? Because a fraction is a ratio, a fraction is a decimal, is a percent, is a rate of change, is a slope, it's a division problem. They're all the same thing, right? So a rational number is a fraction. We see the word ratio right there, okay? So let's not get intimidated by those. And we're going to see some fractions in the form of, or we're going to see some complex numbers with fractions. So remember the form A plus BI, right? So this is the real part, this is the imaginary part. Well, let's go ahead and look at the problem. We have, I have it written down here, I wrote some down, okay, right here, all right? So we're going to have 3 halves, or 3 over 2, it's positive, positive 5/8 I, right? So A, positive B, I, right? It's nothing to be intimidated by. So when we add that to negative 1/4, positive 1/4 I, this is also A plus BI. Now it's negative A, right? No problem. And we remember when we add complex numbers, all we do is we take the real part, and here's our real part, right? We add it to the other real part. We take our imaginary part, right here, and we add it to the other imaginary part, right? So, what do we have? We have 3 halves plus minus 1/4. So we have 3 halves plus minus 1/4, right? So we can just get rid of that plus and just make it minus 1/4. Okay? So we have 3 halves, take away 1/4. We need to find a lowest common denominator, right? And we can see that that's going to be 4. So how do we increase this 3 halves to a 4 in the denominator position? Well, we multiply by 2. Whatever we do to the bottom, the denominator, we have to do to the top, which is the numerator, right? Because it's a ratio. We have to keep that ratio the same, that 3 halves ratio, right? So we end up with 6 over 4, right? And we have to do the same over here. This is 1, this is 1, right? The multiplicative identity, because we already have 4 in that position. So minus 1/4, right? So we have that common denominator, so we just multiplied by 1, or didn't do anything, right? So we worked so hard to get that lowest common denominator. Like I always say, we just keep it the same. So the 4 will stay the same. We'll just subtract 6 minus 1, and that will equal 5/4. Right? And that's positive. Right? A positive 5/4. So on to the next step. So now we have the 5/8, right, plus 1/4. Right? So we bring that down. 5/8, positive 1/4. Right? And we look for that lowest common denominator, and it's going to be 8, right? So how do we get this to an 8? We multiply by 2, and whatever we do to the denominator, we got to do to the numerator, right? Because that's a ratio. We got to keep that thing together, right? So now we have 4 times 2 is 8, 1 times 2 is 2, so we end up with 5/8, positive 2/8. We worked so hard to get that lowest common denominator right here, so we keep it. We just add straight across, we end up with positive 7/8 I. Alright, so we have our real part, we have our addition symbol, and we have our imaginary part, right? Here is A plus BI. So we still have it of the form A plus BI. Okay, don't let the fractions or the rational numbers intimidate you. You know that stuff from basic arithmetic. It's no problem. Alright, cheers.